Hi everyone, welcome to this Build 2020 Home Edition session. My name is Mikkel Mørk. In this session, we're going to talk about a few new features in Azure Kubernetes Service, AKS. We're going to talk about Windows Server Container support and also the support for Azure Spot node pools. I'm going to show you a little tour of these features and share some recommendations on how to use them in AKS. We're also going to look at a few of the recent updates we've made to the AKS service and a sneak peek at the near-term feature roadmap that we have. And at the end of the session, we will have a live Q&A, and my co-worker and co-host Vinicius, who's also here in the session today, will help bridge those questions that you have. Now, remember, throughout this session, there's a chat where you can go and ask questions, and I have another group of great co-workers that will help answer those questions as we go along. So we all know that by running applications today, we have to continuously deal with optimizing, not just optimizing cost in terms of what we pay for servers, VMs, and the compute resources that we use for our applications, but also optimizing our processes around enabling new applications to go into production, scaling existing applications on demand, or even running applications that only required to run on demand. Now, we think that with giving support for Windows Server containers and Azure Spot node pools and AKS, we bring you a set of great features to help with those optimizations. Windows containers were introduced, or Windows Server containers were introduced in Windows Server 2016. And with Kubernetes 1.14, Windows Server containers gained production-grade quality in Kubernetes. Now, Windows Server containers and Linux containers are implemented using similar isolation mechanisms. But what's more important to you is that the tools that you use to create container images and distribute them and store them in container registries, and also deploy and operate them in a system like Kubernetes, are the same set of tools across Windows and Linux containers, which makes it very easy for you to be put on a path where you can apply the same set of operational procedures to both your Windows and your Linux workloads. Now, we brought all these great features into Azure in the Azure Kubernetes service. So what does it mean to apply modern operations to a Windows applications? Well, if we take a look at what a lot of customers, a lot of users are doing today to operate Windows applications, consider a scenario where you need to host multiple applications, maybe from different development teams or even different suppliers on the same set of servers. You need to deal with things like dependency and potential version conflicts that you can have from having multiple applications there. You also need to deal with registry settings and how to automate things like scaling and rollout of these applications. Now, using Windows containers to wrap these applications into portable, reusable runtimes, you put the responsibility and the control of doing the dependency or the work with the dependencies in the hand of the developers. And it helps you get on this path where you can start applying declarative configuration and use control loop systems such as Kubernetes to actually automate a lot of the processes around operating these applications. Azure Kubernetes Service is the fully managed Kubernetes service that we have in Azure. We call it enterprise grade by design because we build in a lot of great features in AKS to help with applying best practices to your clusters. We give you a lot of recommendations on how to optimize your AKS setup through Azure Advisor and the Azure portal. We also help with a multiple layer of security around running Kubernetes. This is not only about securing access to Kubernetes itself, integrated with Azure Active Directory, but it's also how you provide secrets from Azure Key Vault directly to your workloads in your Kubernetes cluster, so that these workloads can securely access external resources, such as an Azure SQL database or Cosmos DB. We also have integration with Azure Security Center to help with security vulnerability scanning, both for your container images as they get pulled into your cluster, or even as they get pushed into an Azure Container Registry, but also at runtime while your containers run inside your cluster. Now, combine that with the enterprise support and the unified management you get through Azure Portal for running Kubernetes inside Azure. So is Kubernetes the right choice for all your Windows applications? Well, it is not for all applications, but there are a few things you can look out for in terms of how your existing applications work, how you could potentially refactor those applications into be good candidates. Now, Kubernetes is definitely appropriate if your applications have all the critical data persisted outside of their processes, and basically have the application work in a way so that a reboot does not cause any data loss. And if you have those scenarios where you also see that reboots can fix these kind of common errors, it's even better. And if you want to have an easy way of scaling applications, having these applications be able to work simultaneously on a shared set of data is also a good thing. Now, speaking about scaling, let me introduce you to Azure Spot node pools in AKS. It is currently a preview feature in AKS. Now, think about Azure Spot node pools, or Azure Spot, as sort of the outlet mall for compute resources in Azure. It's the place you can go and you know you'll get a great price, but sometimes you need a little bit of patience to find the right fit or the right size that you're looking for. So with Azure Spot, what we do is we take unused Azure compute capacity and we're able to sell it to you as a greatly reduced price. In all practicality, what this means is that if you have an AKS cluster and you go and ask for 5 Spot nodes to be added to the cluster, you can go ahead and deploy your workload straight away. If the nodes are ready and the VMs will be added into your cluster, your workload will basically be deployed onto the nodes and it will start running. If the nodes are currently not available either in the Spot resource pool or if they are available at a higher price than you have accepted, your workload will sit inside Kubernetes and just wait for those VMs to become available. And as soon as they're added to your cluster, your workload will start running. But you need to remember it also goes the other way. Spot node pools comes with no SLA, and at any point in time, the VMs can be reclaimed from your cluster and be deleted, which means that your workload will stop running and be evicted from the nodes. So it's important that you find the right set of workloads to use with Spot node pools. So typical scenarios are things where you have background processes that are not time critical to user input. And of course, workloads that are built in a way where they can sustain being evicted and being terminated at any point in time without data loss. So let's go ahead and take a look at Windows Server containers and Spot node pools and how they work in AKS. So let me start in the Azure portal where I'm showing you an AKS Kubernetes cluster. There are 2 things I want to highlight here in terms of requirements on the AKS cluster to be able to use Windows servers and Spot node pools. First of all, your Kubernetes cluster needs to be backed by VMSS node pools. But for Windows specifically, we also only support the advanced network type using Azure CNI. This is not a requirement for Spot node pools. Now, let's take a look at the node pool concept in here. When you create a Kubernetes cluster, you always get a Linux-based node pool. We call this a system node pool. Now, system node pools in AKS is where we run a set of system required components for the cluster to function. We recommend that you have at least 3 nodes in a system node pool in your cluster. Now, you could add additional system node pools, and typically you want to do that if you want to migrate to a new VM SKU or other situations to get a new system node pool. But you need to have at least 1 at any time in the cluster. Whenever you add a new node pool into an AKS cluster, by default, we call them user node pool, or they are of the type user node pools. What's great about user node pools is you can actually scale the number of VMs backing the node pool down to 0, meaning that you can have the node pool and the node configuration in your cluster, but not incur any costs by having that configuration because no VMs are running. And as you can see, I've added a Windows node pool to this cluster. A few things I want to call out about this Windows node pool. First of all, the standard D2S v3 is the minimum recommended VM SKU for running Windows. And you need to be aware that we currently reserve 3.8 GB of memory on these Windows nodes for the Windows and the Kubernetes subsystem. This is subject to change in the future, but at least make sure that you factor this into your capacity planning today. I also want to show you that my Windows node pool or the node pool concept in general, is where we can apply scaling. So on this Windows node pool that I have here, you can see that I've enabled autoscaling. So using the Kubernetes autoscaler, I have told my AKS cluster that this node pool is allowed to scale from 3 and all the way up to 11 instances, whatever is required from my workloads. So let's go take a look inside the Kubernetes cluster and a workload that I've deployed in here. So I'm now in the Windows terminal, and I'm running my VSL2 Ubuntu distribution, or an Ubuntu distribution inside my VSL2 here. And I want to start by looking at my Kubernetes nodes. And as expected, you can see I have 3 Linux-based Ubuntu nodes, and I have 3 Windows Server nodes inside my cluster. I also want to show you that I've already deployed an application. So I created a Kubernetes deployment where I've deployed an ASP.NET application. Now, this is a .NET Framework 4.8 based application, so it can only run on my Windows servers. Now, the last thing I want to show you in here is the pods that are backing up this deployment, and I have 2 of these. Now, these 2 pods you can see are deployed onto my Windows nodes. So how did we make all this happen? Well, let's take a look at the deployment file or deployment specification that I used. Now, I shifted over to VS Code, and I've enabled my send mode to get into a send state with my YAML file here. And as I said, I'm using a deployment type. And the good thing about deployment types is they make scaling operations and upgrade operations really, really easy. Basically, deployment type or deployment object in Kubernetes wraps a pod specification template, which you can see down here. So my specification, notice as a template. And I have a default set of replicas that I run. So by creating this deployment, 2 pods using the template underneath is going to be deployed inside my cluster. A few things I want to call out in here is that I have, of course, assigned resource, both requests and limits to the deployment. So my resource requests are being evaluated at scheduling time by the Kubernetes scheduler to find nodes that have available capacity for this pod to be deployed onto. And the limits are being enforced at runtime, making sure that the processes inside my Windows container cannot exceed the CPU and memory that I specified here. 2 more things in the deployment I want to call out. First of all, I'm using a node selector. And node selectors are used by the scheduler to filter in and filter out which node can be used for running this pod. And in this case, I am using a standard label or well-known label that is applied to all nodes inside Kubernetes to tell which operating system it is. So all this means is that this pod can only run on a Windows node. Now, I also had to add a toleration in here. And the reason why I've done this is that within my cluster, I've tainted my Windows node, saying that only deployments that actually tolerate those taints in my Windows node are allowed to go to the Windows nodes. And the reason why I do that is because we've seen that in the broader ecosystem, there's a lot of examples and configurations that customers go and deploy into their clusters. And typically, these configurations don't expect there to be Windows nodes inside those clusters. So there are no mechanisms built in to sort of filter out Windows as a candidate for a pod to run. So by using the taints in the Windows node and then tolerate them here, I'm able to control and influence the scheduler and make sure that my containers work, sort of land in the right place. So let's go back to the terminal and let's walk through how we can do scaling with this application. So now that I have my deployment inside my cluster and I have these control loop functions inside Kubernetes, what I can do is I can add an auto-scaling policy to my deployment. So as you can see with this command, I created an auto-scaling on this deployment, and I told it to scale the number of replicas of the container between 4 and 10. Now, the auto-scaler in Kubernetes by default evaluates current CPU usage of my applications. Let's take a look at what happened here. I need to get pods. Now you can see I have 4 pods being created, and 3 of them are running, and 1 of them is in a pending state. So if we go and look wide, what I also want to show you here is you can see that the 3 pods that I was running have already been assigned a node to run onto, and those are all my Windows nodes. The 4th one, however, does not have a node assigned yet. So what we can do is we can go and do a description. So we go and describe pod. So let's take a look at this pending pod down here. And what we can see in this output that sort of besides giving me the pod specification, also shows the events around this pod is there are 2 events in here. First of all, you'll note that the default scheduler had a failed scheduling event. So what it did is it went ahead and evaluated those constraints we put into the deployment, and it noted that none of the nodes are actually available for this pod. 3 of them had insufficient CPU, So this goes back to the one CPU request that I put into my pod, and the other 3 didn't match my node selector. Those would have been my Linux nodes. Now, in the case where there are no VMs available, the cluster autoscaler then kicks in. And what this does is it triggers a scale up. And because it knows that this pod needs to go onto my Windows node pool, it is now triggering a scale of the Windows node pool from 3 to 4, adding an extra Windows VM into my cluster to be able to run my workload. So this was a quick tour of an end-to-end scenario of deploying and scaling and how that works with Windows Server containers and node pools in AKS. And by the way, all of this is the same had it been Linux containers in terms of how it worked with scaling and node pools. The other thing I wanted to show you is how to use spot node pools. So I'm back in VS Code again, and what I'm showing you is an ARM definition of what we call an agent pool resource type, which is a node pool in AKS. The reason why I'm showing you an ARM template is that I said this feature is still in preview, so we only support ARM deployments or using the Azure AKS preview extension for the Azure CLI as another way of enabling spot node pools. There's a few things I want to highlight inside the deployment, this deployment definition, this ARM template, just to explain a little bit more about how spot node pools work. First of all, the first thing we need to do is we need to set our scale set priority to spot. This is how we tell the system that we want to use the Azure Spot concept. We also highly recommend that you use an eviction policy to delete, which means that once these VMs are being reclaimed by the underlying Azure infrastructure, the VM is being deleted from the virtual machine scale set that backs this up, and it's also being removed from your cluster. Now you want to combine that with having autoscaling enabled, because with autoscaling enabled, if there are workloads on your cluster that need these nodes, autoscaling will go and continuously poll and make sure that you get the right number of nodes inside your cluster to actually execute your workload. The spot max price is how you specify the accepted max price for these spot nodes. So you can either denote this as putting in a US dollar amount here, or if you do -1, you accept the price to go all the way up to match a standard priced VM. Now, just remember, even though that you end up paying the same price as a standard price, you're still running under the no SLA spot concept. And the last 2 things, you can also see how I'm using labels and tains again. Now, this is the things I put onto my spot node pool so that I'm able, when I have my deployment going in, to select this node label or use a node selector to find the node label to get into the spot node pool, but also using tains to make sure that not all of my deployments land onto my spot nodes. So a quick tour into how Windows Server containers and spot node pools works in AKS. A set of recent updates that we did to the Azure Kubernetes service I want to highlight here. There are 3 great integrations that we released very recently. First of all, Azure Advisor integration with AKS is a way to give you a great set of recommendations to optimize how you run your AKS cluster directly inside the Azure portal. Now, these are all based on the best practices that we see and that we have learned over the years for running AKS, and we also see in how other customers run these clusters. They are all targeted how your specific cluster work and how it's configured today. The Azure Security Center Protection for AKS integration is a way to help you do continuous vulnerability scanning inside your cluster, but also across Azure container registries. And with Azure Private Link for AKS, we're able to provide Azure AKS clusters inside private networks. The 2 other things I want to highlight on this slide is the AKS optional uptime SLA, which we released last week. This is an opt-in financially backed SLA for the AKS control plane, meaning that we will guarantee a 99.95% uptime of the control plane in the regions where we have availability zones. For regions where we don't have availability zones, the SLA will be 99.5. But again, I want to just underline this is an optional financially backed SLA, and it will incur a cost on the control plane. The last thing we've done recently is we released a preview of Kubernetes 1.18 and also a preview of running Ubuntu 18.04 for Linux nodes inside AKS. So a quick look at the near-term future of product roadmap for AKS. We are going to release a new or an improved management portal experience inside the Azure portal for AKS. This is a way where we want to expose the Kubernetes object that you have deployed to give you a better and easier visual representation of what's deployed inside your Kubernetes cluster. We're going to do a managed add-on for the application gateway ingress controller. This is a way where we can easily bridge the native concept of ingress and ingress controlling in Kubernetes with the managed service of application gateway that will give you great features such as web application firewall protection and layer 7 security. We will GA Kubernetes 1.17, and for the Windows side, there's a few updates that will come as well. We currently support Windows Server 2019 in AKS, but we will bring new operating systems very soon. We'll also bring support for Hyper-V isolation, which enables you to run untrusted code side by side inside your Kubernetes cluster. And finally, GMSA for those workloads where that today rely on integrated Windows authentication, and you'll be able to go and run those in AKS as well. If you want to learn more about how to modernize your Windows Server applications with containers, I highly recommend you go and see one of our other on-demand sessions, live sessions, that is, with two of my colleagues from Windows, Moss Imam and Taylor Brown. There are also two on-demand sessions which are already available on Channel 9, which is about Kubernetes best practices and microservices development. So before we head into the Q&A, the two things I want you to remember. First of all, Windows Server containers are ready for prime time, GA production workloads in AKS. And the second thing is, remember all the things I showed you about how we are able to optimize the resources we use around your applications, whether it's how you use Azure Spot node pools or auto-scaling, or even the concept of being able to scale your node pools down to 0. So heading into the Q&A, Vinicius, you have any great questions?
All right. So first of all, thanks all for a very interactive session. We are getting a lot of questions, and our SMEs are also answering those questions. So let's take a look at some of those. One of the questions we have here is there any news when Azure Active Directory or AAD v2 will be GA? I don't think that's specifically related to AKS, but I'll post this question here.
Which part of AAD and integration with AKS?
I think the question is regarding AAD v2 in general, so that's the reason why I mentioned it's not exactly tied to AKS. Any comments on the integration with AKS?
Sorry, no, I'm not aware of that. I mean, the things that we do with AKS is we do AAD integration for authentication inside your Kubernetes cluster. So basically, you can make a connection between cluster roles and AAD. And the second thing I can think of would be a GMSA, where you need Windows integrated authentication for your workloads. That is also coming. I would say the roadmap for GMSA is probably looking at 6 months or so.
Yeah. My recommendation would be for the person who asked the question to take a look at the other sessions on Azure Active Directory during build or contact the product team directly.
Good idea.
Let me see, there's a new question here. Can you confirm Hyper-V is not yet possible for Windows containers?
Hyper-V is possible for Windows containers. Hyper-V is not possible in, well, there is an experimental version of Hyper-V in Kubernetes, but one of the shortcomings with that version of Hyper-V is that you can only run a single container inside the pod. There's probably some other shortcomings there as well. We are working on bringing full Hyper-V support into Kubernetes all up, together with the community, leveraging containerd as a container runtime. So this is something, I think we're on a path to do a beta graduation of the feature in Kubernetes 1.19. So I would expect as we get to 1.20, we can probably have the GA feature for Hyper-V there. That being said, Hyper-V containers in itself is fully production ready, and outside of Kubernetes, you're able to use that.
Yep, that's awesome. The next question is, will the server be shut down gracefully or just powered off? I think that's a question related to Spot node, and the follow-up question to that is OpenDB connections closed.
There is a 30-second grace you get from Spot. So within 30 seconds, you get a notification and the nodes will be shut. So that is basically how it works. So again, it's very important you understand those requirements and you make sure that the workloads you run on the Spot nodes are built in a way where you don't have incur any data loss or things like that when these things happen.
Awesome. We don't have any open questions. Our team is answering the current questions. So maybe one of the things we can do, because we still have time, is go over some common questions on Windows containers and AKS. So one of the questions we usually get is, can I use Azure Monitor for containers with Windows nodes and containers?
Yes, you can. Container Insights and Azure Monitor also have support for Windows. There's currently a few set of limitations to it, which are documented on our doc sites. I actually have a link here on my screen. I'm not sure if the screen is sharing right now, but there's a link to our doc site where you can see what those limitations are. But I also know that we have a preview version of Container Insights or Azure Monitoring for Windows containers in AKS, which is closing the gaps on those feature, those limitations that we have today. The private preview, I'm pretty sure you can find it on GitHub. I don't have a link handy, but if you go troll a little bit of GitHub, Azure Monitoring, Container Insights, AKS, Windows, you'll probably be able to find it there.
Or they can send you a message directly, because your
yes,
email is
there you
right
have it.
there.
My email address is there as well. Go send me an email. I'll send you the link.
Awesome. We should have time for more questions, so keep them coming, folks. Next question is, I've created my Kubernetes cluster before before the node pools feature, or I hadn't known that. So now I can't enable it. Should I recreate the whole cluster, or is there any workaround about that?
If your clusters was not created using VMSS or backed by VMSS, you have to create a new cluster to get VMSS support. There is no migration path for virtual machine availability sets over to VMSS.
Awesome. Before I move to the next question, I saw someone asking about, can I see the recordings of this session? Yes, all the sessions are being recorded. They will be available on May 22nd. So keep an eye for the recordings coming out pretty soon. Next question is, do we have any sessions on how networking works in Kubernetes?
I don't think at Build we have sessions. I will urge that you go and look into the different KubeCon sessions that you might have either through the CNCF site or just I guess you can find them on YouTube. But I know, at least for my learnings from having to learn about Windows Container Networking inside Kubernetes, there's been a lot of great KubeCon talks that have addressed these things. So that would
Awesome.
be KUBECON, KubeCon.
Okay. Next question is it possible to prioritize spot VM when available and fall back to regular VMs when no spot available?
If there is a way to, yes, you can do that. There's a way, I think there's a way where you can combine some node affinities in terms of making sure that things, there's a node affinity. You should look into the node affinity concept inside Kubernetes for your deployments. I'm pretty sure you can do it there.
Awesome. Next question is, any plans to add a UI to manage all this, to allow non-developer users to monitor and add resources when needed?
So today what you see in the Azure portal for an AKS cluster is you see the different node pools, and you have control over the node pool configurations in terms of how they can scale, what VM sizes that are backing them. Now, I briefly mentioned that in our near-term roadmap, we're going to introduce what we call the AKS management portal. So we will enable inside the Azure portal for you to see some of the objects and the deployments you have running inside your Kubernetes cluster. So in that way, it will be easier for you to have a graphical representations of how this is running and what's deployed in there.
Awesome. If I may add one note to that question, I'm also interested in that topic. So if you can send an email to win-containers@microsoft.com, I would love to understand more about that requirement. The next question, and I think we only have time to just one, is the scale up is only CPU based?
The default for the horizontal pod autoscaler in Kubernetes, I think it's the current V1 of that API only works with CPU. I think there's a beta V2 version of the API where you can use any metrics that can be measured and being exposed on the metric server. You can use those for autoscaling, but the default is CPU.
Awesome. Folks, that's what we had time today to cover. We still have some questions coming, and we'll keep answering those. Thanks a lot for your participation, and thanks, Miko, for the session.
Thanks, Vinicius. Thanks for joining.